talking about more on C and Arduino. So the first part we talk about selection in C. So the selection we're talking about is the if and else statements. So what we need to, or the format of the if statements in C is we put the condition on. So if a condition, and what we need to pay attention to that the statements that will be executed once the condition is met, they are put between brackets. So we can have a single or multiple statements blocks inside them. And the way we know they are part of the if statement is they are enclosed with these two brackets. Here's some formatting. So if condition, open bracket, multiple statements, close bracket. The way the else is if condition, we have open bracket, multiple statements, close bracket, then the else. And again, we open a bracket for these statements, multiple statements, and then close the bracket. If we have a nested if statement, we start the same, else, and then we move forward, and then we have the new if conditions under the else. And again, the statements are enclosed within brackets. So pay attention for these brackets where they start, where they end, and make sure that for each condition or else, there's a statement around it. An example of that is we're creating multiple or defining multiple variables here. And then we, for example, integer button on value. Then we're checking the value of the voltage. We having a light sensor value. We having a character which represent whether the keys has been pressed, and integer for the key. So if the button value equal high, then digital write. So we want to put the light at high. If the potentiometer value is greater than or equal to 0, and it is less than 100, then we want to make sure the motor is not working. Otherwise, we want to decide the speed of the motor and make it run. And then we're checking for the light sensor value. If it's more than 500, then we want to print that the light is bright. Otherwise, if it's equal to or greater than 300, we want to say is moderate. If the sensor value is more than 100, we want to say it's dull. Otherwise, if there's no light, if it's less than 100, then it's dark. Then if the key press is equal to 2, then we want to set the key to 2. Repetition, which is a while statement, similar to what we had in Python. Again, while condition, and then the statements that we execute once the while condition is met are enclosed with the brackets. An example is we have a loop here, count equal 1, while count is less than or equal 10. So that's our condition. We want to perform these statements, which is enclosed with the bracket. This is while student name equals space, so it's not equal to space. We want to do a number of statements. We also have a for statement, so the bracket must be used around the for loop expression. There are 3 expressions inside that brackets, and they are separated by semicolons. So these part are the initialized expression, condition, and then increment expression. So for example, this is where we want the for to start. So in this example, we want the count to start at 1. Then we have a condition. So the condition here, we're saying while the count is less than or equal 10, we want to go through that loop, and then we increment that expression. So we increment the count. So that's what keep that counter going up until it reach 10, and that's when we stop. So the condition is evaluated each time that the loop at the top of the loop. The loop is repeated while the condition evaluated to true. The increment expression is usually used to increment or decrement. So we can put minus minus if you want to. This is to execute each time through the loop at the end of the loop. Again, it could be a single or a number of statements, but what we need to make sure of, they are enclosed with the brackets. Any question about this so far? All right. The next part is the function. So function, the first part we'll be talking about the predefined functions. So these are defined by the system. Equivalent when we talked about Python, when we talked about the print, for example, function, that was a predefined function. The following function can be used to convert from one data type to a specified data type. The original value is not changed. So like if we changing from millisecond to second, the amount of second will be calculated the same. So if we have a 1,000 millisecond, which is equivalent to 1 second, when we convert it, we're going to get 1 second. So converting from one data type to another is known as type casting. So we have char, bytes, int, long, and float. So how we format that? So for example, data, we have this variable data to convert to original value. Integer, license value, long, light, intensity. So so this will be treated as a long integer in the following calculation. So light intensity equal long, light sensor value multiplied by this number. So because although that value is stored as an integer, but we want to deal with it as a long in this equation. We also have math and trigonometry function. So ABS return the absolute positive value for a number. The result is the same data type as the value passed to the function. The format of it is ABS, and we put a number there. For example, y equal ABSX. So we're passing x, and what we're getting back is what would be equal to y. Power will return a number, POW, return a number base raised to a power. So the result is in a float or a double. The format of it is the power of the base, and then we exponent. So for example, I want if we have a power of x 3 times, or x cubed, basically what we're looking for in this equation, y would equal x cubed. Square, it's return the square root of a number. So if we put a square and a number, x will be basically the square number of y will equal the square number of x. Sin, cos, and tan, return the sin, cos, or tan as appropriate for angle passed to the function. The angle is in radians. The result is in a float or a double. And the format is sin, and then we pass in the angle, and then we get the result. Number, constant, and mapping function. So some of these we've used already in the lab. We understood kind of how they work, but here a bit more information about them. Min is return the smallest of numbers passed to the function, the minimum number. Format is min number 1 and number 2, so this function will check these two numbers and return the smallest of them. Max is the reverse of that, will return the highest or the largest of the two numbers passed in. Constraint, return a number limited to the minimum and maximum value specified. So if we have a number, minimum, maximum, so for example, constraint sends a value 0 to 255. So we specifying that the minimum number for this value here is a 0, and the maximum number for that is 255. The way to explain how this work is basically if the number we entered is less than the minimum, then the result is the minimum. So if the number less than a 0, then we will stick with a 0. If the number more than 255, then we will bring it back to be 255. However, if the anything else, so if the number within the range of 0 to 255, we will return that number as it is. So if we have -1, this function will return a 0. If we have 300, this function will return 255. If we have 100, this function will return it as it is, as 100. So that's limit that the range of the number entered. This, for example, if you have a device linked to our circuit, and that device can only handle, for example, 255 volts. So we want to make sure that no matter what voltage you ask it to go beyond that, the maximum will be 255. Map return a number converted from one range of value to another range of value. So we use that in the lab. The function only works with integers. Note the value is not constrained. Use the constraint function as well if this is required. So map, we enter the number from low. So from low to from high is the original range to the new low and new high. The example that we used in the lab is we had a range from 0 to 1023, and we changed that to be from 0 to 255. And here's an example of the motor value map, sensor value. We expect the entered or the red value will be in the range of 0 to 1023, but we wanted to restrict it to 0 to 255. Timer function, so a millisecond are 1,000th of a second, and microsecond is 1 millionth of a second. So one of the time function we can use is the delay. So that waits for a specific number of milliseconds. Again, in the lab, we used 1,000 milliseconds for the flashing of the light. So that's equivalent to 1 second. The format of it is delay, and when we pass in the time that we want the delay for, and it's in millisecond. So when we, in this example, delay 2000 is basically we want to wait for 2 seconds before we execute whatever function or statement after it. Delay microsecond. So the difference between this one and the one before is microsecond is basically have a different type. So it deals with microsecond. So 1 million microsecond is equivalent to 1 second. Again, delay microsecond, we pass in how long we want it to wait. An example of here, wait time is 10,000, which is equivalent to 0.01 of a second. mils, it gets the time in millisecond. Since the program starts running, the value return will start from 0. Again, we execute the maximum unsigned long integer size of 4 billion. This is after, so for this one, it could run to count when we start running of the program. The only thing you need to be aware of is this have a limit, because the maximum number it can count to is 4 billion. It's equivalent to about 70 days of running program running. The format is we're just calling that function. We're not passing anything into it. An example is unsigned long time 1, time 2, and we want to check the time difference between them. So we run the first function, we run the second function, and the time difference equal time 2 minus time 1. Macros get the time in microseconds. Since the program starts running, the value return will start from 0. Again, when executed, the maximum unassigned long integer size is 5 billion. This is again after it will reset itself to 0 after 70 minutes of the program running. We run the same way, we call it. So these were predefined function, but also in C, like it is in Python, programmer can define their own function. And again, like Python, there's 2 types of function or subprograms in C. So function that don't return a value, which is void function, or function that return a value. So very similar to what we did with Python. For function that don't return a value, known as a void function, when void function is called, the statement is on a line of code by itself. So the format of it is void function name, and then between brackets, we declare we could be declaring local variables. We can have a single or multiple statement that running in that void function. So that's how we define it. So example of definition: void display message. So this is a function called display message. We open brackets. When this function is called, the action it will be performed, or the statement will be performed, is we will be printing the word hello, and then the second step in the new line we will print the word world. So when that run, it will look like hello world in 2 lines. Example of calls in setup or in loop. So function can be, if you recall, when we talked about C programs, there's 2 distinguished parts of the programs: the setup and the loop, where the loop is it's a part of the program which perform the statements in a loop. So the way we call them is very similar to what we did with Python, void loop between brackets. So we open the bracket, display a message, and semicolon, and then we close the bracket. Again, like Python, we also have function that return a value. So when this is called, when we come back from that call, we will return with a value. So example use of it could be calculation, print line, and so on. The format is return data type, function name, and then data type, program name. So declare local variables. We do a number of statements, and then we return those results. An example of defining them is this is a return the cube of the number passed to the function, double cube, double number, double result, result 1 power of number 3, and then we return the result as for that call of that function. So more compact version of that is double cube. So we declaring that cube variable, we calling the function, and then once that function is executed, we'll return the cube of that number. An example here, return a value limited to a value between minimum and maximum inclusively. It's the same, that minimum less than or equal maximum is similar to the constraint function in Arduino C. So we're defining a constraint to variable, int variable, int minimum, int maximum. Then we declare local variable results. If value less than minimum, then result equal minimum. Else, if the value greater than maximum, then result will be the maximum number that we passing in. Else, result will equal whatever value that we're passing in, and then we'll return the result as part of that call. Again, function can be called from setup or from loop. So, for example, double x equal 1.2, double, we declaring here a variable and we're giving the value, double equal y, and then we call in the cube function, passing x into it. All right. Today's lecture is quite short, but we're wanting to spend more time with the review exercise. So what I want you to do now is for all of you to go and open the open that simulator so that we can create the circuit. I'll just show you a bit more information about that circuit. So if you click on here, you will see information about that circuit that we want to create. So I want you to spend some time creating that. So this will be similar to what we do in our tutorials and labs. Spend some time reading the information here and creating the circuit. Then once you've done that, I want you to spend some time looking at these questions and answer them. We're going to get to a stage where we write the program that runs this circuit. So spend some time doing that and ask me if you have any questions, and we'll go from there. Just in case I lose some of you throughout the lecture, if you're not planning to attend next week lecture, for the exam, I just want to let you know that it will be a quiz style of exam, so it will be multiple answer kind of questions exam. It will be coming from the lectures and labs and tutorials that we had throughout the semester. I want you to really pay attention to the questions and answers because it's that style of exam. Some question might be tricky, so you need to really know the answer. So familiarize yourself with the materials in the lectures and tutorials and labs. Pay attention to the questions and the answers. Sometimes it could be small things that are making whatever the question wrong or right. So don't rush when you answer them, and make sure that you revise all the lectures and tutorials materials before the exam. Anyone have any question about that? No? All right. Thank you. Thanks, Josh, for the feedback. Would be good if everyone give me a thumbs up so I know that you heard what I said. All right, guys. Spend some time looking at these questions and ask me if you have any question, and then some stage I will show you what I've done.